A clever u-substitution. So in this problem, we are going to use u-substitution in really nicer, or let's say uh, sneaky or clever ways. Yeah. And this solution development was contributed by mathematician 6124. Yeah, and thanks to him. And let's see how do we solve this problem. So basically, the first thing we might want to do is try to convert these expressions in terms of 1 by x squares so forms by taking x square commons. And if we take let's say x square from here and x from here, that means basically x to the power 4 from here we will have x cube. Yeah. And since we can substitute these as u's, and this 1 by x cube will be taken in du, and that solves the problem. That can make it easier, not solves, but it can make it easier. So let's try to do that. If we take x square common from here and x from here, basically we have x cube 1 by x square minus 1, and over here it's 4th root of 2 by x square minus 1 by x to the power 4. So we don't really have a really nice expression over here, but if you just notice, if we take a minus common over here, we have 1 by x to the power 4 minus 2 by x square, whose square can be completed. Yeah, so we can complete the square in this expression, and then we get this same expression over here as well, and that's pretty awesome. So let's see, 1 by x cube and 1 by x square minus 1. In this one, when we complete the square, we get the following expression: 1 minus 1 by x square minus 1 whole square. Yeah. So basically, if you open this up, it's 1 by x to the power 4 minus 2x square plus 1, and 1 and 1 cancel out, and we get 2 by x square minus 1 by x to the power 4. And now we make the nice substitution that u equals to 1 by x square minus 1, and that will simplify the problem a lot. And if we make the substitution, we get du equals to minus 2 by x square dx. Yeah, and that is minus du by 2 is equals to 1 by x square dx. Oh, sorry, minus 2 by x cube, not x square. So 1 by x cube dx is equals to actually minus du by 2 by, and now this is u, and over here it's 4th root of 1 minus u square. Now how do we deal with this? Okay, if you just notice, this can be written as u du by u square and then 4th root of 1 minus u square. Yeah, you can notice this thing. You can just multiply by u. Now, if you try to let this as g, u minus y square as g, here's already u du, that's required further in dg, and also here's u square, which can be written in terms of g easily. So that does simplify the problem a lot. Now, if we make this substitution, you get dg equals to minus 2u du. Yeah. And now if we take 1 by 4 common now, then this is exactly the minus 2u du. Yeah. And over here, that's u square. Let me write it as it is for now. 1 minus u square. Now let us make the substitution. We get 1 by 4. This will be dg. And now if 1 minus u square is g, and u square equals to 1 minus g. 1 minus g. And to simplify the stops, or to simplify this expression over here, let us make a new substitution. Not exactly z, but let's say g to the power 4. Yeah, that will simplify this root. So with this, here we don't really have now dg, but instead we have 4g cube. 4g cube dg, and here 1 minus g to the power 4, and over here that's just g. Yeah. And now Okay, also write Fuji cube dg over here. Now after this, this is just now the 4 cancel out. Is that? Yeah. Now the 4 cancel out, and we have g square dg by 1 minus g to the power 4. Now if you use partial fractions, it's easy now. You get 1 by 2 integral of integral of 1 by 1 minus g square minus 1 by 1 plus g square. You can see this immediately, because if you take the LCM, it's just 1 plus g square minus 1 plus g square again, so 2g square and 2 to cancel out. Yeah, you can see that. And now these are some easy expressions. You can do it easily. So this one over here is actually 1 by 2 ln of 1 plus g by 1 minus g, 1 minus g, and this is minus tan inverse g. Yeah, and we have solved the problem. Now let's take g in terms of the original variable. So 1 by 4 ln of, we know that g is actually 4th root of 1 minus u square. Yeah, g is 4th root of 1 minus u square by 1 minus 4th root of 1 minus u square, and then minus 1 by 2 tan inverse 4th root of 1 minus u square plus c. And now what is u? U is 1 by x square minus 1. Yeah, and 1 by 4 ln of 1 plus 4th root of 1 minus 1 by x square minus 1 by 1 minus 4th root of 1 minus 1 by x square minus 1. These are just some general things. Yeah, but it does take time. Yeah, minus 1 by x square minus 1. And I forgot the square over here. Those should be squared. Yeah, I'm sorry for forgetting that. Now this will be 1 by 4 ln of, now this is 1 plus, okay, so basically this is 1 plus 4th root of 2 by x square minus 1 by x to the power 4. Yeah, by this is also 1 minus 4th root of this is also 2 by x square minus 1 by x to the power 4, and then minus 1 by 2 tan inverse this is also 4th root of 2 by x square minus 1 by x to the power 4 plus c. Okay, fine. Now this is the last step. That is to take the LCM, and that gives us x plus 4th root of 2x square minus 1 by x minus 4th root of 2x square minus 1. Yeah, and minus 1 by 2 tan inverse 4th root of 2x x square minus 1 by x plus c, and that is the answer. So this is the answer, and I do think that this substitution should be pretty clever one, basically the first one, to be able to know this thing. But it's not that like hidden as well. Yeah, yeah, you can just somehow notice that this can be made into 1 by x square, and also over here. Yeah, it's not that hidden though, but yeah, it was pretty clever one. Hope you enjoyed the video. Thanks for watching. Look forward to seeing you in the upcoming videos too.